Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
The number of sensors in a modern car is steadily growing. On some cars, their number is approaching 4 dozen, and a significant part of them is designed to improve the composition of the fuel-air mixture and improve the environmental characteristics of the exhaust. The Lambda probe is one such device. Measuring the amount of oxygen in the exhaust gases, it sends this information to the onboard computer, which uses the data to adjust the composition of the fuel mixture, increasing or decreasing the supply of fuel to the combustion chamber. The catalyst present in the Lambda probe neutralizes harmful exhaust components, turning them into harmless or inactive ones. Any failure or malfunction in the oxygen sensors, they are installed on both sides of the catalytic converter, threatens to put the power unit into emergency mode, in which the composition of the mixture becomes enriched and virtually uncontrollable. Not only that, this abnormal situation leads to increased fuel consumption and reduced engine life, but also worsens the environmental parameters of the exhaust. Therefore, it is so important to periodically carry out diagnostics of this note. How to check the Lambda probe in garage conditions? What are the main symptoms of malfunctions of O2 sensors, and whether it is possible to eliminate them through repair, and will be discussed in this informational material. Lambda probe, a detailed acquaintance. Toughening of requirements concerning the composition of exhaust gases is not just a fancy of automakers. For the first time, the harmful effects of automobile exhaust began to be discussed at the end of the last century, when the role of increasing concentration of carbon dioxide in the atmosphere in the spread of the greenhouse effect became obvious. A number of international conventions have called on states to revise their policies to reduce the share of harmful emissions from the combustion of hydrocarbons. And the first to respond to these requirements were vehicle manufacturers, largely due to the emergence of European regulations governing the toxicity of exhaust gases. The presence of a catalytic converter in the car is now mandatory for those countries with Euro standards, which are also constantly tightening. Lambda probe in the car is responsible for quantitative analysis of the oxygen content in the exhaust in the areas before and after the catalytic converter. This information is transmitted to the ECU, which determines the quality of the mixture of air and fuel by adjusting their percentage. Before the catalytic converter, where the first Lambda probe is located, an oxygen sensor checks the exhaust gases that have not yet been treated by the catalytic converter. An additional O2 sensor, installed after the catalytic converter, checks exhaust in which many harmful components have already been converted to safe ones. This dual system makes it possible to determine the characteristics of the fuel assembly with greater accuracy and to adjust the supply of fuel and atmospheric air to the combustion chamber accordingly. So if you are asked what a Lambda probe in a car is, you will be able to give a convincing answer in general words. But you can only get detailed knowledge after getting acquainted with how this device works. The principle of operation of the Lambda probe. As you know, at the present time, there are still not invented ways to increase the efficiency of a technical device to 100%. The automobile engine is no exception. In this complex unit, there are many nodes in which energy losses occur. In particular, the combustion of the fuel-air mixture in the cylinders is not complete, as evidenced by the presence of residual oxygen and hydrocarbons in the exhaust gas. So, the Lambda probe is just a sensor, whose task is to determine the chemical composition of the exhaust. To be more precise, the content of oxygen in it. Normally, this indicator should be within the range of 0.1 to 0.3%. An increase in this value will indicate an over-enriched mixture, which is as bad for the internal combustion engine as running on depleted fuel mixture. Lambda probe in most cases is installed in the end part of the exhaust system, before and after the exhaust manifold. It should be noted that instead of the usual muffler in such cases, there is its modified version, catalytic converter. Of course, progress does not stand still. The design of the Lambda probe is constantly being improved. Two-channel layout as easier to manufacture is characteristic of economy-class vehicles, as well as cars produced since the 80s of the last century. At present, the systems of the broadband type prevail. Such a Lambda probe has a more positive impact on the work of the engine, because it is able to determine the composition of the exhaust with much greater accuracy. If you list what affects the Lambda probe in the car, it turns out that improving the qualitative composition of the fuel mixture is not an end in itself. Thanks to more efficient combustion of the mixture, it is possible to significantly increase the overall life of the power unit, to achieve a noticeable reduction in fuel consumption, as well as to solve the problem of unstable operation of the engine on the XX. If you consider in more detail how the Lambda probe works, it turns out that it cannot form a homogeneous signal because the very principle of the power unit is based on the generation of a heterogeneous number of cycles per unit of time. So we can say that the oxygen sensor in general reacts to the lack of stability in the functioning of the motor and notifying the onboard computer about this is the main task of this device. Simply put, the oxygen sensors send data in real time to the ECU, or rather, to the onboard computer unit specializing in fuel system control, and the data is analyzed there. It consists in averaging the received information and comparing the result with a reference value. The stoichiometric fuel-air mixture, in which one volumetric part of fuel is 14.7 volumetric parts of atmospheric air, is considered as such. This ratio is denoted by the letter lambda and is taken as 1. If the lambda, this is the answer to the question of why the device is called a lambda probe, is less than 1, the mixture is enriched. That is, the volume fraction of fuel is greater than 1. Otherwise, we speak about depleted fuel mixture. ECU corrects the fuel system operation in such a way that the coefficient lambda is always equal to 1, favoring the most efficient combustion of fuel and increasing the engine efficiency to the maximum possible value. If you disable the lambda probe, even with a perfectly tuned fuel delivery mechanism, it will drift off over time. And unoptimized combustion of fuel is the following unpleasant moments: overheating of the power unit, faster wear of all exhaust system components, including catalytic converter, increased consumption of technical fluids, oil, fuel, coolant, rapid burnout of valves, pistons, rings, noticeable reduction of engine power, thrust, in all modes. Therefore, it is so important to maintain oxygen sensors in good condition. Varieties of lambda probes. Although the principle of operation of O2 sensors is unchanged, the ways of realizing the measurement of the amount of oxygen in the exhaust can differ, and the technical improvement of these devices does not stop for a second. Manufacturers constantly monitor all the shortcomings of the probes, trying to make appropriate changes in their design in order to measure oxygen more accurately, increase the reliability and life of the device, to ensure a quick entry into the operating mode. In particular, the introduction of preheating of the ceramic tip of the lambda probe allowed not only to ensure better performance of the power unit at idle speeds during a cold start, but also to significantly increase the life of the catalyst itself. The first generation of oxygen sensors heated up as a result of exhaust gases, which required a certain time, during which the composition of the fuel mixture was not electronically regulated. To solve this problem, it was decided to put the lambda probe closer to the engine, but this step did not allow heating the ceramic tip to the required 350 to 450 degrees Celsius instantly, so for some time the oxygen sensor still did not work. In modern models, there is an electric heater that comes into operation simultaneously with the ignition switch on and significantly accelerates the output of the lambda probe to the normal mode of operation. Read also, geometry of the body and ways to check it. The second direction of evolution was the appearance of broadband sensors, which replaced the two-component sensors. Initially, the system had only one oxygen sensor installed before the catalytic converter, but it turned out that its readings were not very accurate. The installation of a second O2 sensor after the catalyst allowed to increase the accuracy of measurements, and a broadband lambda probe provided a multiple improvement of this indicator. The principle of operation of a broadband-type lambda probe is in the forced injection of oxygen present in the exhaust into a special chamber. For this purpose, current pulses, rated at about 450 millivolts, are used. If the oxygen in the exhaust contains less than the norm, for its supply to the special chamber requires a current of a larger nominal value, which is recorded by the sensor. Lambda probes can also differ in the number of outgoing wires, depending on the specific design and functionality of the device, which can be from 1 to 5. The generally recognized classification of lambda probes is their division into zirconium devices, titanium oxygen sensors, broadband lambda probes. Let's consider their features in more detail. Zirconium oxygen sensors. This type of lambda probes is the most common due to relative simplicity of construction and low cost. The principle of operation of this type of O2 sensors is the use of a galvanic cell with a layer of ceramic coating of zirconium dioxide Z, or O2, as an electrolyte. The dielectric tip has conductive platinum electrodes in the form of plates on both sides. The action of the device is to fix the amount of oxygen ions, which begin to precipitate on the tip only when the latter is heated to a temperature of 350 degrees Celsius and above. To fix the oxygen starts as early as possible when starting a cold engine. A heating element is built into the body of the sensor, which performs rapid heating of the lambda probe. Note that the upper critical point, at which the device can overheat and stop functioning, is a temperature of about 900 to 950 degrees Celsius. In order for exhaust gases to reach the surface of the tip without hindrance, the electrode housing is made in the form of a porous surface. Inside the sensor, the exhaust enters through a special sealing collar that does not allow water to pass through. Oxygen ions moving through the ceramic electrolyte from the anode plate to the cathode plate create a potential difference, which is detected by the sensor and transmitted to the onboard computer in digitized form. The more oxygen in the exhaust, the smaller the potential difference will be, i.e., there is an inversely proportional relationship. Since the sensor operates at a certain frequency, measuring the potential difference several times per second, the ECU interprets these results completely independently of how the engine is running at the moment, which makes it possible to influence the fuel mixture as effectively as possible without relying on various subjective factors. Zirconium oxygen sensors can be 1 to 4 wire. Single-wire devices have a single signal wire, closing the circuit with a contact to ground. A 2-wire lambda probe has a separate wire for ground. 3-4 wire sensors have additional wires for the heating element, supply, and control wires. Titanium lambda probes visually and partially schematically. The oxygen sensor based on titanium dioxide TiO2 is similar to its zirconium counterparts. Here, the sensing element reacts to changes in the amount of oxygen in the exhaust due to the presence of a resistance circuit. The principle of operation is as follows. The sensor input is supplied with a high impedance voltage with a reference rating of 5 volts, which, depending on the composition of the mixture, varies within about 4 volts of the nominal value. The richer the fuel mixture, the lower the resistance at the output of the lambda probe. When the mixture is lean, the resistance increases. The range of change varies from 1 to 20 ohm, which infixes the sensor, transmitting this reading to the onboard computer. Advantages of the titanium sensor: no need to use atmospheric air, lower operating temperature, about 700 degrees Celsius, and, accordingly, a shorter time to enter the operating mode, about 15 seconds. It is also believed that the lambda probe on titanium elements is characterized by greater measurement accuracy. But since this type of oxygen sensor also requires preheating, a heating element is also included in its design. But titanium lambda probes also have disadvantages. The main one is the high cost. Together with a more complex design and high sensitivity to temperature fluctuations, this type of O2 sensors is not widely used. However, to measure its performance is a fairly simple task. This requires an ordinary voltmeter, which is connected to the contacts of the sensor with the ignition off. If the readings of the measuring device fluctuate in the range of 5 to 7 ohms, it is completely serviceable. With large values, up to infinite resistance, we can say that the sensor lies or is defective. Broadband oxygen sensors. This type of lambda probe is characterized by the presence of 2 chambers, a pumping or working chamber, a measuring chamber that records the measurement results. The measuring chamber uses the voltage modulation principle to maintain the reference exhaust composition, lambda equals 1. In the pump chamber, when the fuel assembly is depleted, excess oxygen is expelled through a special diffusion gap. If the mixture is enriched, The deficiency of oxygen ions is compensated by sucking in the required amount of air from the atmosphere through the same diffusion gap. These processes are accompanied by a change in the direction of the current, the value of which is proportional to the volume of oxygen transported. It is this value that serves to detect the value of lambda within 0.7 to 1.7 of the nominal value. Note that the operating temperature of the broadband sensor is even lower, about 600 degrees Celsius, but even in this case the presence of a heating element is necessary. Oxygen sensor malfunction symptoms. For not always the lambda probe fails suddenly and at one moment. In most cases, it happens gradually, stealthily, which makes it very difficult to diagnose the device. Among the main causes of lambda probe malfunctions, leading to an uncontrolled process of fuel-air mixture formation, the following should be noted. Depressurization of the oxygen sensor housing mainly concerns zirconium devices, penetration of exhaust and atmospheric air into the lambda probe, overheating of the oxygen sensor due to malfunctions of other vehicle components, e.g., ignition system, malfunctioning or broken wiring between the lambda probe and the ECU, moral wear and tear, mechanical damage to the sensor, stones, hitting hard obstacles. However, the last of the above reasons can really lead to an instant breakdown of the sensor, but all the others are characterized by a slow deterioration of the powertrain performance. This is the reason why many car owners, especially those without experience in operating the vehicle, do not notice engine malfunctions immediately. But even experienced motorists often do not see the connection between the deterioration of the engine performance parameters and the oxygen sensor functioning. As such, symptomatology may indicate the failure of many other units and parts of the car. As a rule, the signs of lambda probe failure manifest themselves in several stages. At first, the sensor starts to output signals to the onboard computer intermittently, which is mainly manifested when the powertrain is operating in the idling mode. Thus, unstable idling speed is the first symptom that the lambda probe may no longer be coping with its task properly. This malfunction is manifested by floating revolutions and in a wide enough range. Not warmed up, the car begins to twitch. When the engine is running, you can hear pops, which were not there before. In some cases, all this is accompanied by the lighting of the emergency light, which forces drivers to start troubleshooting. But, unfortunately, this is not always the case, so car owners either completely ignore such deviations in engine operation or start looking for breakdowns in the throttle linkage, or CHDPDZ linkage. The second stage is when the sensor provides unreliable data or stops working completely when the engine is warm. The first sign is the loss of the engine's pickup and a noticeable delay when the driver presses the accelerator pedal. Twitching of the car while driving signals the beginning of serious malfunctions in the lambda probe, but the symptom with the most dangerous consequences for the engine is its overheating, which will be indicated by the corresponding warning light or scale on the dashboard. Read also, why do you need a rectitalk and how to make it quiet in such cases? If troubleshooting is not successful, the complete failure of the O2 sensor is almost inevitable, which will cause a lot of problems, including a significant reduction in the life of the powertrain and an increase in fuel consumption. All this will be accompanied by an increase in all the symptoms that appeared earlier. It is not superfluous to remind that the lambda probe, or rather, the catalytic converter, is also responsible for cleaning the exhaust from harmful substances, so a sharp smell from the exhaust pipe may also indicate its failure. The most unpleasant malfunction is considered to be depressurization of the oxygen sensor, as this process can lead to failure of the piston group parts of the power unit, which is fraught with expensive repairs. In such a failure, exhaust gases, at least a significant part of them, bypassing the exhaust pipe, rush into the intake pipe of reference atmospheric air. Any engine braking causes the lambda probe to send signals to the ECU about a significant overabundance of oxygen in the fuel system, which can lead to such failures in the fuel system when the car cannot continue driving at all. The depressurization of the oxygen sensor will be indicated by a noticeable loss of power when driving in high gears, knocking coming from under the hood, as well as the appearance of jerks when moving the car in all modes. If you look into the engine compartment, you can notice the appearance of a large amount of soot in the area of the plugs and exhaust valves. Summarizing the above, let's list the main signs of a malfunction of the Lambda probe. Increase in the degree of toxicity of exhaust gases, illumination of the check engine signal at a sharp pressure on the accelerator pedal, unstable dynamics of the car during acceleration, floating idle speed, crackling sounds in the exhaust pipe area, indicating overheating of the EF, increased fuel consumption. Frequent messages from ECU about over-enriched fuel air mixture. Illumination of check engine indicator when the engine is warmed up. It should be noted once again that all these symptoms may also indicate the presence of completely different faults, which makes it difficult to carry out diagnostic activities. The resource of Lambda probe can vary in a wide enough range, from 60 to 120,000 kilometers, but when the car is operated in harsh conditions, which is typical for Russian realities, this term is noticeably reduced. Characteristic reasons leading to premature loss of functionality of the oxygen sensor are the use of sealants not characterized by resistance to high temperatures, most silicone sealants, when installing the Lambda probe, ingress of engine oil particles into the exhaust as a result of wear and tear of the cylinder, regular use of poor quality fuel with high content of heavy metals and ethyl, overheating of the oxygen sensor due to incorrectly set ignition angle or as a result of prolonged operation of the power unit on over-enriched fuel, faults in the electrical circuit, broken signal wire, short circuit to ground, poor quality contact group. 2. Frequent attempts to start the engine due to malfunctions in the injection system, which causes fuel oil penetration into the exhaust system, mechanical damage to the sensor. Ways of diagnosing the Lambda probe. Since the CAN-KD bundle works in extreme conditions, experts recommend checking the serviceability of the Lambda probe every 10,000 kilometers, regardless of whether the signs of its malfunctions listed above have appeared or whether the sensors work in normal mode. The primary inspection is visual. So, consider the sequence of actions to check the operability of the Lambda probe with your own hands. Disconnect the Lambda probe terminal and check the O2 sensor for the presence of mechanical damage. Dismantle the sensor from the manifold. Perform visual inspection of the protective casing for the same purpose. If there are contaminants, clean the casing. Presence of soot on the Lambda probe. Tip indicates that the engine is running on an over-enriched mixture or a malfunction of the electric heater, which leads to clogging of the CD and reduction of its reaction time to changes in the composition of the fuel mixture. Presence of deposits of whitish or grayish color testify about active use by the owner of the car of additives in fuel or If the sensor tip is shiny, this is a sign of using fuel with a high concentration of lead, which leads to rapid wear of the catalyst and oxygen sensors. In all these cases, it is necessary to take measures to eliminate the causes of fouling, and the Lambda probe itself is desirable to replace it with a new one. Note that visual inspection is not always able to detect failures in the operation of the FC, so it is recommended to use methods involving measuring devices. Diagnosis of the Lambda probe with a multimeter checking the oxygen sensor for malfunctions is carried out by several characteristics. Voltage level in the circuit of the electric heater, the presence of a signal from the sensor to the ECU, heater check, reference voltage. Let's first describe how to test the Lambda probe with a multimeter for the presence of voltage in the electric heater circuit. Turn on the ignition. The sensor does not need to be dismantled. Connect the multimeter contacts to the electric heater circuit. The +1 is connected to the sensor directly from the battery, preferably through a fuse, the -1 from the onboard computer. Readings on the tester should correspond to the nominal voltage of the battery, 12 V. To measure the reference voltage, use the same scheme, but the measuring device is connected between the mass and the signal wire. Multimeter readings should be close to 0.45 V. Diagnosis of the heater is carried out a little differently. Multimeter is switched to the resistance measurement mode. Disconnect the connector from the sensor. Measure the resistance level between the contacts of the electric heater. On O2 sensors of different types, the multimeter readings will differ, but do not exceed the range of 3 to 10 ohms. Measurement of the oxygen sensor signal is carried out according to the following algorithm. Switch the multimeter to the voltage measurement mode. Start the power unit. Let the engine warm up. Connect the terminals of the measuring device to the mass and the Signal wire of the oxygen sensor. Increase the crankshaft speed up to 3000 RPM. The voltage should change abruptly within the range of 0.1-0.9 V. Non-compliance with the recommended values indicates a faulty sensor, which in most cases must be replaced. Checking the sensor with an oscilloscope. An oscilloscope is a device that allows you to make measurements with the recording of time, intervals between the pulsations of the output voltage. Here is the sequence of actions describing how to determine the malfunction of the Lambda probe with an oscilloscope. The contact of the measuring device is shorted to the signal wire. Start the power unit with warming up to operating temperature. Increase engine speed up to 1900 to 2600. Observe presence/absence of deviations in the oxygen sensor operation. If the time interval exceeds 120 milliseconds, or voltage readings are outside the limits of 0.1 to 0.9 V, it is possible to assert about the Lambda probe malfunction. Other methods of diagnostics. The presence of ECU already allows you to significantly narrow the scope of fault finding. It is enough to connect an auto scanner to the onboard computer to clarify the reason for which the check engine indicator lighted up. Here is the list of errors related to the Lambda probe. Error 0130. KD1 sends incorrect data. Error 0131. The signal from KD1 is too low. Error 0132. The signal from KD1 is very high. Error 0133. KD1 is late in sending data. Error 0134. No signal from KD1. Error 0135. KD1 heater is defective. Error 0136. Short circuit to ground in KD2 circuit. Error 0137. The signal from KD2 is too low. Error 0138. The signal from KD2 is very high. Error 0140. Break in KD2 circuit. Error 0141. KD2 electric heater is defective. Error 1102. DC heater has low resistance. Error 1115. DC heating circuit is damaged. Availability of auto scanner will allow to determine more precisely the cause of oxygen sensor failure, saving time and effort when carrying out diagnostic works. In conclusion, understanding the various types of Lambda probes and their serviceability is crucial for maintaining optimal engine performance and reducing emissions. By familiarizing yourself with the characteristics of each type, such as zirconia and titania probes, you can make informed decisions about which one suits your vehicle best. Regular checks, including voltage tests and resistance measurements, can help ensure that your Lambda probes are functioning correctly. By staying proactive and monitoring these components, you can enhance your vehicle's efficiency and longevity. Thank you for watching, and we hope this information helps you keep your engine running smoothly.